So welcome to our Retrofit Meets event this evening as part of our Retrofit 24 series. I'm Laura Broderick and I've been working on the programme here which launched in March and is running through to the end of August, all about the reuse of our commercial, cultural and civic buildings. We've had a range of events. Hopefully some of you have attended our panel discussions previously or our webinars and walking tours, but delighted to welcome you to this specific event, which is Solutions for Decarbonising Heritage Estates. If you've had a chance to look upstairs in the exhibition, you'll see that the theme of heritage runs through quite a lot of the projects from whatever classification, commercial, cultural and civic, and it's something that we've celebrated in past conversations, and we looked at solutions for heritage estates as a whole. But tonight we very much want to celebrate those solutions from a product manufacturer and supplier viewpoint and how those solutions can flow through those heritage estates where we know there's often complicated issues at play and a menu of retrofit options to choose from. So we've got a fantastic lineup of speakers. I'm not going to introduce them because we've got a chairperson with us tonight who will do that. But just by way of practicalities before we get started, there is no fire drill, no alarms planned. So if there is an alarm, it is for real. So we will evacuate the building. So just so you know, to be attentive to that. If you can turn your phones to silent or off, that would be much appreciated. Speakers included, please. So that would just help us kind of concentrate on the conversation. The way we run these events, as I say, I will shortly hand over to our chair, who I will introduce. Each panellist will in turn speak for 10 minutes, and then we'll have a Q&A at the end where panellists will regroup together and you as the audience can put your questions to them. So do think of your questions along the way. We won't be stopping between each presentation. We'll do that collectively at the end, but do keep them in mind as you go through. So to welcome our chairperson, I'm delighted we've got Josh McCosh of Heyningen Haward Architects. He's a partner there and leads on a lot of the reuse projects with a heritage slant. And the Holton School project that some of you may know has won various awards for retrofit and reuse, including the RIBA Reinvention Award, and is one of the projects showcased upstairs in the exhibition with a fantastic case study and model to sort of celebrate that project. So that is something Josh may reference in his introduction in a moment. So we're delighted that Josh could join us to chair tonight. He's also working on a new LETI guide for non-domestic retrofit, which will be released, I believe, in the coming months, and is a companion to previous LETI guides and will obviously help support the industry at large in kind of making the right decisions with projects in the non-domestic sector. But as I say, as a practitioner, as an architect, Josh has got lots of experience on many projects across education and heritage, and the kind of reuse in the heritage sector will, be invaluable today as he leads the conversation and chairs us. So once again, thank you for attending, and I'll hand over to Josh. Thank you, everyone.
Hello, everyone. Can everyone hear? So the office thought I was hilarious that I was asked to chair because in their version I never shut up and keep talking the whole time, so it's going to be interesting. But I'm interested to chair this because the practice has been involved in what is now called retrofit, and I think the word is kind of not important, the idea is, really since it was founded. And we've always thought it very odd, the idea that because a building is old, you might chuck it away and build a new one. There's such value in old buildings, whether they're what would be put in the heritage bracket or not. My perspective working on the LETI guide as a small cog in a very large group of volunteers was trying to persuade people why retrofit might be better than demolition and start again, which I think is an active debate on Oxford Street currently. I think from our point of view, the creativity of the wide industry is worth thinking about, because I think almost every building can find a viable reuse. It might not be the use it was intended for, but the interesting thing about heritage buildings is, by all standards, they should be the most difficult and complicated. And yet, in this country, actually, we retrofit heritage buildings really well. There's a huge body of people do it really well. I'm just going to touch on the four things that I think that relates to. And the first is often not said in these conversations, which is about comfort. You know, if a building is uncomfortable or doesn't serve its users, it doesn't get used. In the heritage estate, that means it becomes dead weight. And so I think retrofit can offer better performance. It can keep people working in that building. It helps companies retain staff and even attract staff. And the sort of concept of wellness, which is another bad word in my book, but it's an important concept, comes into that. The next one is adaptation. In the heritage estate, probably the single biggest threat to heritage now is climate change. You know, we have, you know, I don't think if you'd said 10 years ago there will be a wildfire in London that will remove a street of houses, that would have just seen as unthinkable. Yet it happened last summer. There are lots of heritage buildings which have rainwater goods that were designed for 400 years ago, and if the building floods, it's bad news. So I think retrofit also encompasses a level of climate resilience, and there's the whole issue that you need to make sure that a building has viability for the use, and that use might change, and just running costs. You know, if we don't retrofit old buildings, even heritage buildings, and I think what's interesting is the statutory consultees' lens has changed, and they now recognise that performance of buildings has to be improved if they're going to be preserved. So, for instance, we're working on a scheduled ancient monument now at the Chatham Historic Dockyard, where we are ostensibly recovering a lead roof. We are also insulating it, which would have been considered unthinkable not that long ago. And yes, we'll do it very carefully and we'll think about it, but it's on the discussion, and Historic England are kind of with us on that journey. And then the big thing is decarbonisation. All this comes back to decarbonisation. I mean, James will speak from the client's point of view in a moment, but I think what's interesting is our other speakers will show how there are kind of real practical techniques which are in use now. And although they are all from three particular manufacturers with three particular angles on what they do, they sort of stand in for fabric, thinking about building fabric, for thinking about your energy source, and thinking about, in the context particularly of heritage estates, how do you move that heat around? Because you can't always put the energy source or the heat source where you want it. So our first speaker is going to be James Basey, who's architect and surveyor at the National Trust. He works sort of South Downs and Hampshire. He probably has the widest portfolio of anyone in the room, I'm imagining. And therefore, this is his daily kind of dilemma. How do you improve the performance of a widely disparate estate of buildings that all have real value? Previous experience in private practice in London, working on heritage and retrofit of historic buildings in both residential and commercial. And so I think it will be interesting to reflect on how he sees his current role. Our next speaker is Dave Tiller, who is a sort of Ventrolla old hand, would that be fair? But that comes with it 43 years of experience thinking about how you stop energy being wasted in buildings, and also how you keep quite a fragile bit of the building in good repair. And I think we all know, if we think about heritage, someone said that repair starts with gutters, or decay starts with gutters, but second on the list must be windows. You know, if the windows are failing, your building becomes uninhabitable. And so from the fabric point of view, Dave's going to talk about windows, but some of those lessons are applicable wider. Chris Newman is the Zero Carbon Design Manager, to give him his proper title, for Mitsubishi, who make lots of heat pumps. And so he will talk about the kind of opportunities, the challenges, the differences that heat pumps make in the context of heritage environment. He started in I suppose where heat pumps are thought of completely normal, in refrigeration and cooling, and of course now we run them backwards, and sometimes we do both. So he will talk to us about that and how that might help us get to net zero for, I suppose, what are our challenging building stock. I always think it's a doubtful statistic, but you know, at any one time, probably 80% of our buildings exist. So if one says the heritage ones are the tip of the iceberg, I think those techniques will become just kind of wholesale adopted as we make those 80% fit for the future. And then last but not least, Steve Richmond, Head of Marketing and Technical at REHAU, is going to talk to us about how you might distribute that heat. And in the context of a heritage estate, I think that's interesting. The Halton project upstairs has 2 electrically fuelled buildings and 2 gas-fired buildings because the DfE wouldn't stump up the money for the electric. But what's interesting is there wasn't room in the historic buildings for the heat generating plant, even though it's quite small because it's gas boilers. And so the heat goes from A to B underground, and that's where I think Steve can shed some light. So I'm now going to hand over to James, and I hope we'll think about questions, and I'll try and conduct them in a vaguely competent way at the end. Thank you.
Okay, good evening, everyone. Which way are we going? Let's check this. Yep. Okay, so my name is James. Architect working for the National Trust. I cover the portfolio of Hampshire and the South Downs. So anyone who's good at geography, that's Winchester to Berlin Gap. Is a big portfolio, really diverse, big challenge. I'm going to try and set the scene today as the client, and then we're going to hear some solutions afterwards, hopefully. I'm sure most of you heard of the National Trust, but just in case you haven't, a very brief backstory. So we were founded in 1895, so we're just over 125 years old now. And one of the early quotes from us is to promote the permanent preservation. And that really is at our heart now. We are all about preservation. And we do everything we can to preserve as much as we can. And we are hoarders in a way, and we like to hold on to things. So we're an independent charity, and today we're Europe's largest conservation charity. We've got a really big annual income, 680 million. There's a lot to do with that money, as you'll soon find out. 5 million members. I think we've got more members than Costa Rica has population, and there's 10,000 members of staff working across a broad range of disciplines. So this is what we're doing today. 620,000 acres of land, miles and miles of coastland, 200 historic houses. We've got 147 accredited museums, castles, chapels, lighthouses, bridges, barns, you name it, we've got it somewhere. So the need for climate action. I won't touch on this too much, but as we all know, we're getting wetter, warmer summers, we're getting more mild winters, things are becoming drier and hotter, and sea levels are rising. And in the Trust, we've looked at this, and we think that 70% of everything we own will be at a medium or high risk of these climate hazards by 2060. So for us, this is a really big, at the front of everything we do, problem. Again, to put this into context, we've got 28,000 buildings across England, Wales, and Northern Ireland. I don't look after all 28,000, fortunately, but sometimes it feels like that. And importantly as well, and what makes us unique, potentially, is the 1 million items we have. When you go to the National Trust, lovely buildings, but also all of those paintings, carpets, rugs, tables, chairs, everything else we have, that sometimes is what is, depending on what building you're visiting, sometimes you're there for the building, sometimes you're there for the collection, sometimes both, sometimes it's the cafe. It really is a mix. Josh touched on this, understanding the threats to our collection. So heavy rainfall, again, we've got historic buildings, extremely small gutters, sometimes non-existent, and we're getting more rainfall now. And that really is one of the key areas that we are really suffering. And the maintenance of that is obviously critical, but ways to adapt to that and change that is also important. Extreme heat, Josh mentioned comfort. Chartwell, for example, got to 36 degrees inside in 2022, which isn't a place that anyone wants to visit or work or be for any prolonged amount of time. And so the viability of that as a building really does start to fall off a cliff if you can't fix that. And also unpredictable levels of pests. The more mild the winters are becoming, we're seeing a big increase in the pests. And we have a lot of timber structures that are very sensitive to these wood-boring beetles. So that's a real challenge for us. And these are sort of 3 big things. And we're starting to see this already. So the monitoring we're doing is increasing dramatically. We're seeing that the drier summers we're getting means the changes in the ground condition is moving. And these buildings, as you know, they move, they crack, and we're constantly chasing around to try and keep up with it. So our goal as an organisation is that we're going to be net zero carbon by 2030. I won't go into how we're doing that, but very briefly, we're looking through the lens we have adapted as the Trust is the climate race. So reduce, adapt, capture, and engage. And for us, there's some opportunities where we can do all of this. Sometimes it's a pick and choose option. So this picture here, if I touch on it quickly, This is at Cragside in Northumberland, and it's up the stream. And this is a watercourse that comes from a river that was built in 1878. And then at the bottom we have we've got to write this down because this is one of my properties. We've got a 70-metre long turbine. And essentially what we're doing here is we're also recording a podcast. So what we're about at the Trust here is doing good work and sharing that with everyone and saying to people, look, we've done this, it works, maybe it doesn't work. And that's part of the whole approach that we're really trying to do here. So building adaptations, I'm going to pick on because I thought that was a good one to... There we go. So, mentioned earlier, the sheer scale and diversity of the heritage we have is our real big challenge. And it wouldn't be unusual to have these 5-6 buildings within one portfolio, within a stone's throw of each other. And as you can see, every single one is completely different, and they will all have different problems and different approaches. And so there really isn't a one-size-fits-all for this. And so our adaptation approach is built around a sort of series of core principles. And I think the important ones to bring out here and to bring your attention to is there is no end goal for us. We are forever, for everyone forever. And so it's not just what can we do in the next 20 years to hit a target. This is here for the nation. We are not selling any of these buildings at any point. They're here for us forever, future generations. And so that idea that we're going to have to constantly change and adapt to an unknown future is really at the heart of what we do. And also working in partnerships with others is very important. And one of the ways we've done that is trying to identify where to adapt. It's all very well saying we need to adapt our buildings, but what we've done is we've created this hazard map. And the two images I've got here quite nicely shows the predicted changes in overheating from now to 2060. And as you can see, captured London here where we are, it's pretty dire reading. So we've got this hazard map, and what we can start to do is understand where different buildings and different portfolios have different challenges and what they might be and what they look like. So some of the preliminary considerations when we're doing any works to a historic building is, would the works be effective and compatible with the way the building performs? So as I mentioned, our stock is really diverse and really different. So it's really important to know about the building characteristics, the construction, and then also the way it's used. Some of our buildings are vastly populated. We'll get over 1.5 million visitors a year. Some of them might only get a few hundred. And knowing that building inside out and intimately is really important. Would they harm the significance of the building and the wider area? It goes without saying that everything we have is basically listed. That's the assumption you start with, and then sometimes you get lucky and one of them isn't, and you can be a bit more radical. But assessing that significance is again really important. And then also that leads on nicely to what planning permissions or consents would be required. So again, most of the time when you look at a building, it's at least grade 2 listed. We have a lot of grade 1 listed buildings. They're in conservation areas, they're in AONBs, they're in all the things that make the buildings lovely is also the things that make them a challenge. And so looking at adaptations and significance, I think what's important here is that what we would do in one place, we wouldn't do in another place. So Bodiam Castle here, grade 1 listed, and you look at that and you just scratch your head and think, I don't even know where to start with that. We've got a moat around it for us, for example. So we talk about how do we get heat to that castle. It's all very well if we have land somewhere else, but that interface is a real challenge. Two very quick examples of how different, again, our stock is. This is a farmhouse in Snowdonia, and it literally is at the base of Snowdon. Second wettest region in the UK, and the challenge we had here is the climate has been getting wetter and wetter, and the increase in storms has been driving the rain into the gable end. And we always start quite sensitively. We do masonry repairs, repointing, and we got to a stage where it just wasn't working, and the building, although it gets wet in the winter, it wouldn't do its natural dry out in the summer. And so what we did is we actually adapted the building, and we put a whole new gable of slate on the end. And this is a grade 2 listed building, and this was a great example of how you can work with planners and work with those local authorities and come up with solutions that fix the problem and adapt, but in a nice, sensitive way. This is the other end of the spectrum. This is Wimpole Estate, again, grade 1 listed. You look at that and you think, I don't know where to start with that one again. But the fantastic thing with some of these places is not only do we have these mansions and fantastic houses, but there's normally thousands of acres that come with them as well. And so what we did here is we had a new car park development, and it was a perfect opportunity to put a borehole in and solar panels. And again, designed sensitively, that was located out of the sight of the house, and it meant that we could make those proactive steps forward. And then might touch again on heat distribution later. But you know, we've reduced our carbon by a third, by 47 tonnes a year. There's enough electricity there to heat 113 UK homes. So it's really, you know, quite significant. Again, no standardised approach to the way we go about any of this in the trust. And the thing I'd always come back to is that one size really doesn't fit all. So although we do learn lessons, we almost go straight back to square one with every single building we look at. And then I think it's important to emphasise that we really try and adopt a whole building approach. And what's important that is, it means that although we might have a whole building approach, we can't always go in and have, you know, £500,000, do a deep retrofit and then leave. Sometimes it is a case of, here's our end goal, but because of funding, we have to do small incremental changes. But it's understanding that when we do A, what happens to B over here, and what that process looks like over, you know, 5-10 years. Because we are a charity, we don't have that, some of the capital reserves that some of the other projects the guys might talk about. But understanding that as a whole is really important for us moving forward. And again, that feeds back into the for everyone forever. You know, sometimes with us, there's no rush because we're going to be here forever. So we want to get it right. And then finally, just to finish on this slide, just wanted to sort of touch on that importance for us about the balancing act between mitigation and adaptation. And so they'll be talking tonight about using clean energy, you know, and as an estate, we can look at, you know, bringing down the way we source our food and sustainable transport. But also we feel that there needs to be more in adaptation and, you know, and more from the government. And I won't get too political now, and there's other people in the trust that are pushing agendas forward there. But this was a nice little slide just to finish on and say it really is a bigger picture, and just unfortunately sometimes I want to run in, do a building and disappear again. It's a bigger organisation to sort of look at. That's a whistle stop tour. I've gone very quick. I hope you took it all in. But yeah, I'll answer some questions later. Yeah, it's a bit temperamental.
It is, isn't it? Hi. Sorry, you have to put up with me. I'm just getting over a cold, but I'm not contagious, honestly. My name is Dave Tiller, as it says there. We've just opened with a strap line of the windows of the eyes of heritage estates, which I think you'll agree, windows being a very important part of the fabric of the buildings, or any building. Who are Ventrolla? We are the UK's leading timber sash renovation business. We've been established for 40 plus years. We were established in Harrogate in 1983. We have undertaken over 1 million projects with an estimated 6 million window renovations over those 40 years across royal, heritage and civic properties. The name Ventrolla comes from a portmanteau of ventilation and control. I think you all agree that windows are very important in keeping heat in, but it's very important that we ventilate houses. The amount of condensation problems, health problems we have, so it's very important that we have that control for various reasons in heritage buildings as well. So we don't, for argument's sake, a typical example of a property I went to, a Tudor come Georgian aspects. They introduced central heating into, this was several years ago, central heating into the property, sorry. And then after 3 months, they were woken up by cracks in the night, like a rifle going off. It was actually the oak panelling on the stairwell that was cracking through the stress of being dried out, all the moisture of the wood. So it does have a detrimental effect on the fabric of the building. So it's very important ventilation. Heritage estates, I think we'll all agree, they're living testaments to the history and culture that have shaped who we are and how we live. At the same time, all these properties are now inhabited by modern families, so it's vital that we keep them warm, safe and healthy. So coming from a sort of a domestic, although we're talking commercial sort of view. Sorry, I'm jumping ahead there. We're Windows offer the most vital aspect of the building fabric. Improving the performance of windows reduces energy use and increases comfort. Better insulation and airtightness lowers heating and carbon emissions and can also reduce energy intensity by 38%. Upgrading windows in heritage property preserves historic value. Windows are the main elements that impact thermal performance. That significantly affect the comfort, heat loss and ventilation of the property. And we all know that a lot of 15, and it's arguable that 15% above heat loss is through your windows. So we know there are 8,600 conservation areas and about 4,000 listed properties in England. The most sustainable buildings, the ones that are already built, for the last 40 years, we've worked on windows up and down the country, and we've arguably been taking this forward by retrofitting draft-proofing systems and improving the energy efficiency of windows and buildings for the last 40 years, and also giving the opportunity, as I say, to ventilate properties. There's 5.9 million buildings built pre-1919, 4.3 million built pre-1944, 2.8 million buildings in conservation areas. 17% of the UK's carbon emissions relates to buildings. Maintenance, periodic renewal, and sorry, my voice is going. And sorry. Cheers. Thank you. I do apologise. Refurbishment saves 30 to 50% carbon emissions. So, really quickly, what can we do to help windows? Basically, when I do surveys, I cover surveys commercially, domestically, up and down the country, and we wide-ranging from listed buildings, conservation areas, but generally, when it was set up, we just did draft proofing on single glazing, so you can get 30% energy efficiency on draft proofing a window. So a typical window with a 3mm gap around it, 12 by 1800, is equivalent to a 200mm hole in your wall. So if you're sealing that up with draft proofing, you've got that energy efficiency. We've got statistics to back that up that was tested in a house in Leamington Spa. Over the last, I would say, 15, 20 years, we've had the introduction of heritage double glazing, which is always a sticky point in listed buildings. Recently, with vacuum glazing and passive glass glazing, that seems to be a big thing now that we're getting asked to tender for in commercial properties, especially. And to be fair, it is going in some listed properties. So some councils are looking at it for the attributes and future-proofing it because of the attributes of vacuum glazing over and beyond the regulations now, but future-proofing it for the future, obviously. Ventrolla draft proofing, as I said, it achieves a 30% more efficient window in the energy rating. So exceeds class 3 of BS 6375 with standing winds. So that's gusting 71 miles an hour. Reduced air changes down to 0.4 air changes an hour. And the decibel rating, if you're filling those gaps up, it does help with the sound as well. And it is termed significant of 6.6 to 10 decibels, the improvement. But sound is always subjective, whether it's reverberation noise or airborne noise. We can try and do something about the airborne noise, but unfortunately, reverberation noise we're always going to struggle with. So just to give you a taste of one of the projects we are working on now, so we brought it up to date. We could go back in the past, but so George Cadbury was a Quaker. He set Cadbury's up late 1800s, but he actually built the factory in 1900s, which is when he bought a lot of land. He just didn't want to build houses for all his workers. He wanted to build a community. And I think recently there was a good documentary on the way people were, churches, shops, doctors, etc., etc. So, you know, it was really well set up, really well thought out. It's him and his brother. His brother's name escapes me, but the goal for BVT was to provide vibrant communities rather than mere homes, with traditional and community values being important factors. And that is steadfast. So it stood the test of time. And I recently have been there and surveyed the windows. And when I'm talking to some of the occupants, they've been there for 40, 50 years, and their parents before them. So it's quite touching, some of the stories that come out. Each property represents craftsmanship from Tudor-style cottages to Victorian townhouses. And I can verify that because I've had to survey all these properties. So he just didn't build rows and rows of houses. Believe me, they're semi-detached, most of them, and they are all different configurations. So it's not an easy job to go around and measure these windows. So far, we have retrofitted 24 properties, and we're currently working on additional 26 new properties. Other contractors were involved, however, they were unable to replicate historic features, and as such, Ventrolla has become one of the main suppliers now. What we've done, on the windows, so you can see the old black and white windows and the coloured ones there. The windows, the houses are very similar, but believe me, they've had casement windows, sash windows, a mixture of casement, sash windows in the same properties. It's a real mixture, but that's what makes them unique. Historical preservation, timber window renovation, energy efficiency, quality assurance. But I think from that picture there, you'll see that the main part for us was that we maintained what it looked like. So what we did as a team, we sat down with the trust, which was very important. So we did a window inspection. We customised the solutions. We had skilled craftsmen on site. So that's joinery and installations. We've got our own joinery shop. So we was able to replicate all the joinery we needed to put into the properties, which is those frames, believe it or not, those casement frames are 130 mil wide. When you look at today's windows that go in, mainly PVC, 70, 75 mil into brickwork. So that is a credit. Those houses weren't cheap to build, and they are rock solid houses. We had a collaborative approach. We listened, we worked with the architects, we worked with the trust. We also worked with some of the occupants that formed up the trust as well. So it was very collaborative. And I think you'll agree with the net results you can see in colour as well. So our achievements, preservation of our heritage, our commitment to historic preservation was not only maintained the charm of the Bourneville village, but enhanced it for future generations to come. Energy efficient solutions, the upgraded timber windows now meet modern energy efficiency standards, contributing to sustainable and cost-effective living. Client satisfaction, Bourneville Village Trust is extremely happy with Ventrolla's work, and as mentioned earlier, Ventrolla is currently working on 26 new properties and will continue to work on properties in the near coming future. They've got a 5 to 6 year program, so this is going to be on running, it's not going to stop, and it's all funding considerations. Obviously they can't do it all in one hit. So this was a customer quote. We go around, we take very much care in the customer so the client is their house. So unlike these larger buildings, people are living here. We've got dogs, cats, babies, families, just everyday living. So generally, it was to work around everyone's needs and requirements. As a trust, it had different requirements for different occupants, so we had to consider that as well. We are still considering that with new properties, but it's working with the trust to make sure it goes seamlessly. So thank you for listening, but I just did put these in as well because I thought this was interesting. So Roundtree House, common theme. I've not gone over my 10 minutes, have I? Oh, nearly. So I'll just shoot through this, but there was a reason. So obviously another connoisseur in chocolate, another Quaker, etc., etc. An interesting fact down there, in 1857, George Cadbury worked there as his apprenticeship before he opened his own factory in Birmingham. So, you know, it's I think it's quite touching that we chose that and this building here. And I won't talk on the last slide, honestly. I'll just show you that. So this again, in Staffordshire, working on windows of various types in various positions, like you've shown us, James, on those buildings. It's not one fits all. It's all different. Is that right? Sorry about my voice. I was struggling.
Hi, hello everybody. Thank you very much to Retrofit 24 for asking me to come along and talk about my favourite topic, which is heat pumps. My teenage daughter, if she's ever struggling to sleep, will always ask me to tell her about it. As it says here, my name is Chris Newman. I work for Mitsubishi Electric. So I'm here to talk to you about heat pumps for decarbonisation. Obviously, somebody's got to talk to you about heat pumps because it's the most important thing that we've got between now and 2050. So today it's me. And I thought the way to do this would be to just break it down into really two simple topics. As Laura said, I've only got 10 minutes today, so we'll do our best to try and get through as much of this as we can. So we'll look at net zero and carbon emissions and why heat pumps are important in that area, and then we'll actually look at some solutions and some key considerations. So starting off with looking at net zero and carbon emissions, we all talk about net zero being a long way in the distance. Well, I like to think of it, it's only 307 paydays before we've all got to be at net zero. It's not really that far when you look at it in those terms, is it? And quite often, it does seem to be a bit of a destination without a map. And as a result, a lot of people struggle with what we're going to do, how we're going to do it, and when we're going to do it. And I think the closest thing we've probably got to having a map is the government's carbon budgets and the nationally determined contributions to carbon emissions that we're all signed up to. And I know there's a lot of information on this chart for you guys to see, but broadly, the amount of carbon emissions in total from the UK is mapped out and planned to get us to net zero by 2050, set out in these carbon budgets. And as you can see at the moment, we've been okay with carbon budget 1, 2, 3. We're into carbon budget 4 at the moment, but there's some really big drops coming in the future. And as you can see on that current trajectory line, we are not going to achieve at the moment, according to the Climate Change Committee, anywhere near the carbon reduction that we actually need to get to our legally binding commitment of net zero by 2050. But the government have doubled down on these commitments and said that by 2030, we need to get to 68% less carbon than we had in 1990. And by 2035, that needs to be 78% less carbon than we had in 1990. And as you can see, that is a hell of a drop over a really short period of time. And heritage buildings, obviously there's an awful lot of them, as James said before, they're going to play a big part, as well as all of the other 1.7 non-domestic buildings across the UK. So if we zero in on the carbon emissions that come from buildings, this comes courtesy of the UK Green Building Council, and this shows the carbon emissions across domestic and commercial buildings. Now this sector, the second one up, which is the kind of lighter bluey colour, these are the carbon emissions from non-domestic buildings. And you can see there's a huge amount, around about 100 megatons of CO2 attributed to non-domestic buildings. And again, following that business as usual line, we are not going to get anywhere near where we need to be. So non-domestic buildings are a really, really important part of how we're going to do carbon reduction. So just a really quick overview of why is a heat pump lower carbon than a boiler. Everyone seems to think they know why it is, but just to give you the actual information. If you look at a gas boiler that takes gas into it and burns it, obviously that produces CO2 emissions. And according to Part L, a typical gas boiler today is 93% efficient. So we would need 2.6 kilowatts of gas to go through a 93% efficient gas boiler to produce 2.5 kilowatts of heat. And from a heat pump point of view, we use electricity to drive a heat pump. Electricity comes from the national grid. Unfortunately, we still do burn a little bit of gas and a little bit of coal in order to produce electricity on the national grid. So there are carbon emissions that come from the use of electricity. But a heat pump is able to harvest some renewable energy from the outdoor air or from water, adding that to the electricity that it consumes in order to produce those same heat output. And again, the example I'm using here is 250% efficient heat pump. That comes from the Part L standard default figure. We think we can do a lot better than that, but just to give you the examples from Part L. So when it comes to electricity, this graph comes from the Future Energy Scenarios document produced by the National Grid every single year. And this gives trajectories as to what the anticipated carbon emissions for electricity will be as we move forward. And each one of these different colour lines is showing you different possible outcomes, depending on how we all in this room approach decarbonisation. Even the worst case scenario, which is this kind of dark grey line at the top, which is what they call falling short, shows that over time, carbon emissions on the electricity grid are going to fall dramatically. What I've overlaid over the top on this slide here is the current Part L building regulations assumptions for grid emissions if you use gas, 210 grams, 0.210 kilograms, and for electricity, 136 grams. So for every 1 kilowatt of gas you consume, you're producing 210 grams of carbon. For every 1 kilowatt of electricity you consume, you're producing 136 grams of carbon. So what does that actually mean when you then compare a gas-fired system to a heat pump system? Again, really simple example using the standard Part L defaults, which I've got at the top of this slide here. We take that 1 kilowatt of gas, we put it through our gas boiler, we've emitted 210 grams in order to produce that 1 kilowatt of gas. And then as a result, that means that we're actually producing or emitting 225 grams of carbon for every kilowatt of heat that you get from a boiler. You run exactly the same scenario through a heat pump, again using that Part L default of 250% efficiency. We take 1 kilowatt of electricity, which has got 136 grams associated with it. We run that through our heat pump at 250% efficiency. And as a result, we're getting 1 kilowatt of useful heat in our building for 54 grams of carbon emission. So we're talking 76% less CO2 for the same amount of heat generated. But for any of you guys that work in commercial buildings, the really important metric moving forward is energy usage rather than carbon emissions. Because as I've just showed you, the amount of carbon associated with the amount of energy is a changeable figure. So EUI, energy usage intensity, is the really important metric. And when you look at it in these simple terms, it's half the EUI to produce the same amount of heat. And as a result, that is why everybody wants to talk about heat pumps. That is why heat pumps are being seen as the long-term answer. So just to move on to those heat pump solutions and some of those key considerations. I mean, when it comes to heritage buildings and retrofitting any existing building, the problem that we typically have is that there's high temperature systems, usually gas-fired, 70, 80 degrees C. We've usually got oversized boilers. There isn't a proper energy thermal analysis done on the existing building. There might be existing heat emitters and pipe work which isn't necessarily easy to work with. There's usually no plant space. There's usually no electricity. And then we've obviously got the problems of how much does it cost to buy and how much does it cost to run. So it does sometimes feel like trying to force a bit of a square peg into a round hole. But as I said before, these are solutions that we're going to have to come up with. And what I'm trying to show on this chart really here is, again, heritage buildings particularly problematic in this area, is that the existing heat emitters are not really easy to replace, easy to change. And as you reduce the temperature of heat that's in a heat emitter, you get less heat come out of it. And this chart is trying to give you an example. If you have got something like 70 degrees C in your existing heat emitter and it's giving you the correct amount of heat for your room or for your building, as you start to reduce that temperature of heat in that heat emitter, you're getting less and less and less heat from it. And that can be a real challenge, especially when you're trying to maintain the same level of heat in a property, and if you're trying to reduce the temperature to get better efficiency from your heat pump. This is ultimately where the challenge comes in. So what do you do about that? Well, obviously one simple option is you put bigger heat emitters in, or you put more heat emitters in. But that's not always going to be possible. I'm sure James might have a problem with doing that in some of his heritage buildings from the National Trust. The other option would be to simply increase the flow temperature and put the temperature in the heat emitters exactly the same as it would be with a gas boiler. And we can do that, and I'll talk to you about that in a minute. But it's not always desirable. And obviously the third option is to try and reduce the amount of heat you need in the first place. Now for a heritage building, that can be really difficult. Maybe Dave can help with some of the window solutions and some of the other fabric solutions, but ultimately it is really difficult to reduce the amount of heat that you need. So when you look at heat pump systems, it isn't just for individual dwellings, individual domestic properties. Some of the heat pumps that are available, and this is by no means the full range of heat pumps that we offer as a manufacturer, but anything from 3, 4, 5 kilowatts right the way up to over 1,000 kilowatts from a single system is absolutely possible, absolutely viable. This is not new technology. This is something that even us as a manufacturer have been offering to the market since 2008, 2009. It's a very, very old and well-trusted and well-used technology, and the solutions really are there, but you've obviously got to apply them in the right way. So as an example here, if we were trying to heat a building and it was less than 70 degrees C temperature that was needed, that's really easy to do from an air source heat pump. We can just plug it directly into the existing heating system, no problem. But if you can reduce that temperature down to say 55 degrees or lower, the number of heat pumps on the market that are available to you multiply dramatically. The options of size and shape and refrigerant and all of the other different things that come with it become more abundant. If you do need to go high temperature, then we can do that. We can mix an air source heat pump and a water source heat pump together to deliver really high flow temperatures, easily up to 75, 80, 85 degrees C. But actually what might be more prevalent moving forward and a bit more pragmatic possibly is to look at using heat pumps alongside the existing heating system to try and make those first steps towards decarbonisation. I mean, hot water is a relatively straightforward thing. It's probably not massively prevalent apart from the cafes that David James was talking about before. But actually hot water is really easy to achieve from heat pumps using things like CO2 refrigerant or using cascade arrangements where air source and water source connected together. And these are really standard solutions. But using that figure again from the UK Green Building Council about how we've got to try and reduce these carbon emissions, maybe the appropriate way of doing it, where we are today, traditionally using boilers, move that towards adding some small amount of low carbon energy from a heat pump, then maybe switching that balance and making the heat pump the predominant amount of heat delivery into that building, and then ultimately get rid of that fossil fuel system and move towards a completely low carbon heat pump solution. When you kind of summarise where they are and why aren't we already doing this now, is if you look at from a carbon point of view, as you can see on the left-hand side of this graph, is that no matter what heat pump solution you put forward, because of the figures and the metrics I showed you earlier on carbon emissions and grid emissions, you will always be lower carbon than a fossil fueled system. That's really simple to understand. And the different solutions we're putting forward here is a bivalent solution of heat pump plus boiler, a cascade solution of 2 different heat pumps working at really high temperature, and obviously the optimised lower temperature heat pump solution. But the problem often is that when you look at an operating cost point of view, because right now gas is cheap, gas is typically a third of the cost of electricity, is that the operational cost of those solutions can be a challenge for a client, can really be a challenge. And that's probably the biggest barrier, along with the capital cost, as to why heat pumps aren't being more prevalently used. But as you can see, even with these disproportionate gas to electricity prices, there is ways to get the operational cost to be in parity. There are ways to overcome the high temperature challenges and the retrofit challenges that we need. So I think, obviously, finishing up really, I do think there's a heat pump for all solutions. If you want any more information on some of those things that I've talked about, appreciate we've only got a short presentation today. Please have a look on our document library. You'll be able to download individual guides on all of these different solutions like bivalent and cascade and things like that. And other than that, it just remains for me to say thank you very much indeed for your attention. Really appreciate it. Hopefully that was useful to some of you guys, and I look forward to the panel discussion afterwards.
Okay, good evening, everyone. So my name is Steve Richmond. I'm the head of marketing for REHAU, and I'm going to talk about some of these solutions. Now we've generated that heat, let's see what we can do with it. So for those who don't know REHAU, I like to think of as the biggest company you've never heard of. We're 20,000 employees worldwide, 4.5 billion euros. It's a German polymer company and actually celebrating our 75th year anniversary. So some people might know us from underfloor heating, some might know us from PVC windows. We also do bumpers for Audi, BMW, Mercedes. We do things for IKEA and Howdens on edge bands. It's a huge range of polymer products, but I'm going to talk about pipe work. You like to talk about heat pumps, I like to talk about pipes. So, on the left-hand side, we talk about district heating and heat pumps. You now know what a heat pump is, so let's talk about what's moving the heat. District heating is using a pre-insulated pipe. I'm going to show you one of those in a second. So that's more moving the heat once you created it on these heritage sites. On the other side, I'm going to talk about the pipework inside the building. So O-rings is a key potential weak point on a pipe system, so I'm going to talk about how you can get O-ring-free plumbing. Underfloor heating, again, we talked about heat distribution within the building. We do a lot of things like churches, things like underfloor heating, because you don't want to heat your radiators, that heat just goes straight up. You want that nice radiant heating and keeping it low down. So lots of heritage buildings do actually retrofit underfloor heating. So let's go in a bit more detail. So, pre-insulated pipe for district heating. District heating is a very common concept, especially across Europe, but it's getting more and more common in the UK. So instead of having an individual boiler in each property, you're having one very large boiler, you can see on the left-hand side there, creating that heat. You then distribute the heat through underground pipes like that, so that's a flow and return pipe. These are very well insulated, and then you're moving that heat to each building, and that could be commercial buildings, residential buildings. It's more of a concept, district heating. And the government's putting a lot of money into it, and there's a lot going on. But you can think of a heritage estate. I mean, James talked about the size of the estates. You're basically doing a mini district heating network on it. But one of the great things about district heating is that it's technology agnostic. So it could be a gas district heating network, obviously older ones, but it could be a heat pump being the heat source. It could be biomass, anaerobic digestion. That's the great thing about it. You can change the heat source after the pipes are in the ground. So it could start off, back to what we were talking about earlier, how you can change the heat source and things, add things to it. A gas system done 10 years ago, you can swap that with a heat pump. You might have to change some of the temperatures around. And what I've highlighted on the left-hand side there is what we're seeing in our design team is that a lot of the new district heating networks in the UK are using heat pumps. That could be ground, air, or water source, or waste heat. Admittedly, waste heat might not be as relevant on a heritage site, it's more in inner city urban areas, but it's a huge amount of waste heat going on, or getting wasted in the UK. It's actually a great source to catch that heat and put it into a district heating network. So that's district heating. What you also have is, what's talked about earlier, just having an external plant room, effectively, an energy centre. So you might not want to put that heat pump on the side of the property because you've got a lovely grade 1 or 2 listed building. So you might put it 20 metres away, 100 metres away. And that's where it's a sort of a simple A to B type connection of moving that heat from that external heat source to the building and use the same type of pipe work there. So whether it's district heating or a heat pump, it's still a very well insulated, pre-insulated pipe. So when it comes to the internal plumbing and pipe work, say for your heating in your hot and cold, I think pretty much every system on the market has an O-ring. So you've seen it on sort of plastic push fit, on copper pipes, or press fittings. They all have O-rings. And O-rings are always a potential weak point in a system. And also, you don't want water leaks in these impressive listed buildings or heritage buildings. So that's one of the reasons we get involved in a lot of these projects is they've had leaks in the past and they want to get rid of those O-rings. So that's where we sell on the back of that system. So our system is it's two-part. You have the fitting and the sleeve, and that is it. There's no O-ring hidden inside there. The pipe is expanded. You can see on the right-hand side, it's pushed in, and then a tool slides that sleeve over. One of the things about it is when you see that sleeve done to the end, you know that fitting is done. So for a contractor's point of view, you're not like, oh, have I done that right? When that sleeve's got to that point, that fitting is good, and you're not going to have an issue. And that's one of the reasons people use us on heritage buildings, for that reliability of the joint. So that's a simple visual inspection. We also have lead-free fittings. So when I say it's lead-free, it's a bit like alcohol-free. You have certain sort of percentages you can use. And there's a gradual transition to get rid of lead. And it's also not made of lead. They have tiny amounts of it in the alloys. But we've now gone way surpassed the drinking water standards. We've now got lead-free fittings and all the gunmetal transitions when you have a threaded fitting. We use polymer fittings where we can, but when you need a metal fitting, we now got lead-free fittings. So again, we're way sort of future-proofing the system going forwards. And also we have a cavity-free joint. So what I mean there is water, you can't make it a little dead leg, water can stay there over time. So avoiding that, you don't get any potential microbial growth sitting in that water. So it's trying to really get rid of any cavities of the system. And what's one of the most exciting thing, we've had this system for many years. We've now launched a bio-based solution of it. So as you know, polymers come obviously from fossil sources. What you now can do is actually make a bio-based polymer. So this comes from things like vegetable fat, so like used cooking oil from like a fish and chip shop or whatever it is. That can get reused and actually make a bio-based polymer, which I think, I can't get my head around it, but you can do it. And it's great, you can actually make that same pipe from vegetable fats and things, which is that's the way the market's going to go, obviously, not using fossil fuel sources. So you can really get a 90% reduction in CO2 emissions by switching to a bio-based polymer from a standard polymer. So you can see there's a lot of innovation going on in the market. And I think you'll start seeing a lot more of that in general sort of plastics going forwards. So we get involved in a lot of these projects from a variety of angles. There's not a simple sort of route like when someone gives REHAU a call. So from the client side, it could be the clients used us before, very happy with it and want to use us on a future project. But I think, as I mentioned, a lot of the problems when people had an issue with an O-ring on a system or had a leak, and a leak's obviously a huge issue when you might damage paintings or whatever it could be or something, but leaks are critical to avoid. So that's where a client might call us up, but also there might have some corroding steel pipes underground. It could be a 20, 30 odd heating system between two buildings and those pipes have failed. And when a pipe fails, it really just disintegrates some of those pipes over time. So they want to place it. But back from the architect's point of view, so they might think, oh, can I locate this energy centre away from the building? Can it be 10 metres? Can it be 100 metres? Can it be 500 metres away? The question is typically yes, but people come to us with those kind of questions. And then when it comes to the building services engineer, the consultant involved, so they might want to check what is the heat losses, what kind of pipe sizes do I need for these flow and return temperatures? Have I got the right routing? We've got many years' experience of this. We might say, actually, maybe don't put it there. You might want to go around that way. There might be a better way of doing it. We also check the suitability of the application as well. And from the contractor side, they also might use it before already, but might be what REHAU pipes are specified. So really, there's no kind of typical route we get involved, but we do come across a lot of these projects. So I'm just going to show a few examples. I wasn't born for it, but there's a show in the 70s called The Prisoner. Who remembers that one with the weird bubble? So that was filmed in Portmeirion in North Wales. The bubble's chasing the guy, I'm not quite sure why. So this put in a 1 megawatt biomass boiler. I think it's actually in the display upstairs, isn't it, Laura? So it's a 3-kilometre district heating network in North Wales. It rains a lot, I think you mentioned earlier. And it's also a lot of slate. So you can see in the bottom right picture there that actually to try and excavate the actual trench for it was good fun for the contractor. But they did get there eventually, then you then put a little sand bed around the pipes. But it just shows you can do them in difficult conditions. They also had a 40-metre height difference, so you have to factor it in when you're sizing the pipes, obviously to pump it up that height difference. So, and they installed 29 buildings at the start. They've done little extensions over time. I believe it's actually just a hotel and a holiday cottages, which are all these buildings. I think there's a swimming pool there as well. But it just shows you can get it in quite difficult conditions. This is another one in Scotland. So Fort George is an 18th century army base. Now you can see it's got that huge walls around the side of it. And the challenge they had here is there's only a tiny little gate to get into the building, obviously to stop invaders as it was at the time. So we had to get all our pipes into that thing, and you couldn't go through the tiny holes. Effectively, a quad bike could get through there, and that was about it. So the contractor had to crane all the pipes, every single pipe and things, and everything over that wall, which was a huge feat. They did it, but it just shows the kind of weird and wacky things you might get in historic buildings. You might think a lorry can just turn up, drop the pipe, and drive away, but it's not always the same on a heritage building. So Raby Castle in Durham. So this was a 2-kilometre network. I believe there's an open loop ground source system, 200 kilowatts, and I think it's sort of the first step. We want to keep expanding this system. They're building a lot of new buildings on the estate. So it's they built a mini district heating network. They can keep expanding over time. So I mean, it's a very impressive building there. It just shows they're trying to really reduce the CO2 there. So already at 40% reduction. I think that will continue as they expand the network. I could go on for a long time. We've been involved in many projects. I think a few of these are national trusts, I think, aren't they? But just a few examples. Hull Maritime Museum on the left-hand side, that's a very impressive building. And we renovated a lot of the plumbing pipework in there because I had a lot of failures on the plumbing system. Obviously didn't want that in the museum environment. Plas Newid, if I'm saying that right, Anglesey, I think that's National Trust, is it, James? I think it is in the bottom right corner. Yeah, there's a lot of them out there. But that was a water source heat pump from the sea, I believe. They actually did it from the Strait of Anglesey, Anglesey Strait, sort of getting the heat out of there and things and into the building. Other ones are there being a mix of biomass, heat pumps. You can see some of the coils of pipe there. We get some quite fun shots with the building behind us and a massive coils of pipe. So it just shows there's a huge range of projects out there, and it's not sort of one size fits all. Some are sort of heat pumps, some are biomass, all different shapes and sizes. So sort of what we've learned on these things is sort of, I think early involvement is key. So when we get involved in a project, it might, if it's quite late in the day, they might have sort of done a sort of strange route and that makes it more expensive, or the sizing might be a bit oversized, like, are you sure this is the right size you need? But a lot of just general technical support, like, can I do this or that? So I think when we get involved in a project, we can help optimize. It's not just the OPEX, it could be the sort of CAPEX as well, because it's simple things like they might do a T of a certain size. We actually think it's cheaper doing it that way. If we've done these kind of things, it's cheaper to do that transition, like an extra pipe going that way, or they just think logically to do it one way. So, and back to plant location, we talked about it a few times. Choose the best location for the plant will move that heat. I think a lot of people think, oh, it's going to be a huge issue. Hundreds of meters of pipe, you might lose 1 or 2 degrees we're talking about. It's not like 20 degrees heat you're losing. So you really can, not saying go to put it 5 miles away, but you really can put it on the edge of the estate if there's aesthetic reasons or for planning permission or whatever. These pipes are very well insulated, so you sort of tell us where you want it to go, and we can then tell you how much heat it's going to lose. So it is very, very flexible what you can do. A lot of people come to us, well, who's going to install pipes? I've never seen these pipes before, so I've never seen. So I think, again, with us, we can advise people to install it for many, many years. You do it day in, day out, so you at least know that confidence that it's going to be installed correctly. I think my final slide is, we do some fancy projects as well. That's not UK, if anyone's been to Barcelona. Is it Familia Sagrada? Is that Sagrada? Familia? I can't remember what it's called. But yeah, we did underfloor heating in that. So it just shows that even in pretty impressive buildings, 200, 300 years old, I can't remember exactly how old it is, it does seem like a lot of work, but for churches or cathedrals, it's perfect kind of thing, not trying to do radiators on the side or anything like that. Just they're clearing out the central area, getting rid of the pews and everything, putting the underfloor heating and replacing the floor. It really does work in historic buildings. So that's quite a good testament to it working. And I think that's it from me. So.
Have to do a bit of logistics with furniture, so I'm going to invite you guys forward. And Aaron, if we could have the lights up a little bit and the slide off, that would be amazing. Are you happy to move those through? And I will be on roving mic for when Josh directs questions. Oh, perfect. We'll get that off in a sec. We've got about 20 minutes, Josh.
I'm sure you'll tell me when we've run out of time. Well, I see people drifting upstairs on it. Okay, good.
Yeah. Thanks, Aaron.
Okay.
Yeah, is that okay?
Can you see? Yeah.
Yeah.
So we thought we'd really like to have questions from the audience. If all of you are feeling bashful, I'll have a go at starting. But I think what strikes me is, if you like, the diversity of solutions. I think it would be interesting to know from the kind of the installation angles, what in your respective markets, I suppose, what you think you really can't do, because the suspicion I get is you can do almost anything with the limits of your system. So I'm curious to know where the boundaries of those are, and how you think that's going to change, because my perception is a lot of the boundaries are either financial or legislative, not technical, and that's something I'd like to talk about a bit. I mean, whoever wants to start, we can just...
I can answer really simple. One current problem, we couldn't replace a steam-fired system with a heat
Too
pump.
hot.
Be really, really difficult to try and achieve that with a heat pump. So if it was steam, we would be looking to reduce that and change that to a lower temperature. Hopefully, you haven't got too many steam systems in heritage buildings. But yeah, that would probably be a non-starter for us.
Yeah, yeah. Dave, from your point of view, what's the one that you wish you could deal with you can't, or you think in the timber windows market you can do almost anything?
I think from a window perspective, it's always comes down to listing what you can and can't do. And there's no, you go from, I cover the whole country and listed building officers, and we get on with them. So I'm not knocking them, I'm just saying that they have different views on different products. So you're quite right. People have designed heritage double glazing to come down from 70s, 80s double glazing to look ugly, to fit in side lines. But then now we've got passive glass or vacuum glazing, and the people's attitudes or conservation attitudes to change. Some embrace it, and we'll talk through it with you on projects, and it will be allowed to be put in. Others won't, and they just say no, it's secondary glazing, which arguably secondary glazing, it puts a different perspective on the window. So it's really awkward. I wish my 64 now, all I want is central government to make a remit to local governments to say, right, guys, you need to concentrate, and this is how we can collectively do it in a constructive way now, because I honestly believe with the skill sets we haven't got coming through, with all the guys in this room, including myself, is we have a chance to make change in a sympathetic way to these historic buildings. Because, and I'm not knocking next generations because I've got a grandson as well, but when they come through, I don't know if they'll be as sympathetic. So that is my qualm, really.
What do you think?
Technology was not just like saying with heat pumps, you can get bigger pipes and things like that later. Okay. So I didn't bring the 350mm pipe. I thought it was quite heavy to carry. But no, you can get very big pipes, the same principle. I think the challenges more come if there's maybe a very large river crossing or something like that, but any sort of special prefabricated things. I mean, sometimes you can just avoid it, just go slightly longer round, but there's not too, I think more the hurdles like the sort of capex and things like that which are doing it.
And James, in terms of your perspective, I'm guessing that from a client's point of view, you're not really bothered by the menu of solutions. You're just looking at the end point and the impact on the listed fabric, if it's listed, of how you get there, or the environment.
Yeah, I mean, as a client, we're on board, so we don't need to be sold to in terms of, we understand the issue. So that's an easy one for all the guys with the solutions. The challenge is you can pick any estate we have, and you've got a Grade 2 star listed mansion in the middle, and then you look to the side and there's another pavilion that's listed on its own, and then you look behind and there's a parkland that's listed, and then there's a scheduled monument at the entrance, and then you turn around and go, oh, there's some archaeology there. And so for us, you sort of start to scratch your head and think, I need a district heating system, and although we can put it far away, it does become, logistically, where do we put it? We've got a property up Arc. It's up on the hill in the South Downs, lovely spot. It's incredibly remote. Everything you look at is listed or protected, and actually, unusually, we don't own all of the acres of land around it, and so it's an incredibly tight site to get everything on, and it's a real challenge. So, again, it's you can pick 100 different properties, and they've all got 100 different challenges. But yeah, trying to thread that needle through in terms of if we're just looking at particularly distribution, that's the tough point.
So I'm just curious. I'd love other people to put their hands up, but from your point of view, where does that journey start? Probably does that start at looking at the, if you like, the constraints, the boundaries of that estate, or are you more focused on the kind of metrics of carbon and money and program, or is it always a bit of both?
It's a little bit of everything.
Yeah.
And again, we touched on it earlier. I think we've got so many specialisms within the trust, and everyone has their own agenda per se. So trying to keep everyone happy is tough. And some people are a little more protective over adapting buildings and changing them. And for them, much like the building regulations, that heritage does trump everything. And that it does become a natural fallback. We don't have to do this because we're listed or whatever the designation we have. So it really does vary between property, management and the way we've got the Central National Trust, but we're actually quite a devolved setup in terms of every region has their own. This is your responsibility. You look after it as you see fit, essentially, and so you do need to get buy-in from those on-site teams.
Yeah. Have we got anyone who's willing to stick that up? Oh, thank you. We've got two. So, gentleman there first.
Hi. Is it on? Just don't think it's on.
Yeah, I think it is if you point it quite close.
John Willman from Conservation Officer at Westminster Council. I've got a couple of questions. One for on the aircon issue. Sorry, on the air source heat pump. We get proposals for air source heat pumps, and I've been told by architects that if you run them in reverse, they're aircon units and do cooling. Is that the case?
Absolutely. An air conditioning unit and a heat pump are the same thing.
Right.
Internally within the refrigeration circuit, because it's all refrigeration technology, we are literally pumping the refrigerant round the opposite way within the circuit. So all a heat pump does fundamentally is move energy from one place to another. So when you're operating it as a cooling piece of equipment, you're taking heat usually from the inside of a building and rejecting that heat to atmosphere, to the outside with an air source heat pump. If we reverse the cycle of refrigerant around that system internally, then what we do is we absorb heat from the outdoor air and then we reject that heat into the building. So it's exactly the same process, quite literally running the opposite way around. So every heat pump usually can also cool. In fact, every heat pump at some point will need to defrost itself if it's an air source heat pump, because the outdoor unit has got to be colder than the outdoor air temperature in order to get energy to move from the outdoor air into the heat pump system. And as a result, the outdoor coil will usually be colder than the outdoor air. And once we get below about 6 degree ambient, you start to get frost forming on the outdoor coil. So a heat pump, to get rid of that frost from itself, will actually reverse and operate like a cooling unit, only for a few minutes, but it will do that in order to get rid of that ice from itself. So some manufacturers will make their unit heating only, specifically for their own choice, but fundamentally the technology is exactly the same that's in all of the equipment. Hopefully that answers. Great.
And so on the alternatively, is every aircon unit an air source heat pump? If you turn it, can you turn them to work the opposite way to do heating instead of cooling?
So terminology is terrible because everybody uses different terminology for the same thing. But an air conditioning unit, like a VRF system, for example, you might have in your offices, or an air conditioning unit that you might have in any application, a retail store or a data center or anything like that. Any air conditioning unit, if it's using air as its energy source and not water, as I think Steve mentioned before, if it's using air as its energy source, then that is an air-sourced heat pump. Whether you're choosing to operate that air-sourced heat pump in cooling mode or in heating mode is purely just the control of the unit.
Chris, can I butt in here? Russell Jones, I work with Chris at Mitsubishi Electric. I think what we need to clarify as well is what you're doing with the heat pump. So if you're going air to water, that is what most people term a heat pump, because you're getting hot water out of it. If you're going air to air, that is what most people think of as air conditioning, because you're getting hot air or cold air out of it. Is that fair to say, Chris?
Yeah, it's fair to say. The technology is the same. You're simply moving energy from one place to another, whether you're absorbing it from the building to cool the building and rejecting it outside, or absorbing it from outside.
I'm curious about the rationale, or the reason for the question.
Well, air conditioning is energy hungry, and it's fine. Air conditioning.
Yeah, I thought this where this might be going. Yeah.
It's a very sustainable thing to do, whereas air source heat pumps are considered.
So interestingly, I went to a school we did recently in the summer to find that the building manager had quietly flipped it over and was running it in cooling mode, which is really serious because their energy bills would go up by 25% that year if they left it on. And we did have a word with, it's quite a small school, we had a word with the head teacher, but we also changed the BMS so it wouldn't do that. And I mean, most units you can lock out the cooling mode for a good reason. And in this country, in my view, virtually no building should need cooling that's not really densely populated or got process in it. So I think it's a matter of being mature about one's understanding of the system, both in terms of legislation and permissions as much as technology.
Heating is deemed as a necessary requirement to make the building, you know, habitable, whereas usually cooling is more a preferable, you know, to make it preferable rather than a requirement, unless you've got overheating concerns. Of course, you know,
Where's the rub though in planning terms?
Yeah.
You can make,
Yeah.
there's an argument to be made that you can cause harm to a building if there's an environmental benefit, because it's a public benefit. You can't use that for comfort cooling because
No.
it's essentially unnecessary in many cases.
Yeah. I think and I think it's really difficult to enforce. I think it's a challenge.
that's what Part O of the building regulations is there to try and help you decide whether you're going to be experiencing overheating in a building that's excessive, in which case cooling would be potentially required if you can't use a passive measure.
Good evening. Stuart Ellis, Conservation Accredited Structural Engineer, with an interest in energy efficiency. And I've heard talk of that we're overheating our buildings by heating up the air, which then heats up the building fabric, and it's sort of wasted energy in a way, and possibly a move to using the air heating to a much lower level to have a lower background heat, and then use radiant panels on demand to heat the occupants when they're there, which strikes me as being much kinder to the building fabric and more energy efficient, because
I might start with James, because I think James will come at it both from a fabric and a people point of view. But there's recently a very interesting study about historic buildings using a strange combination of underfloor heating and open fires, which actually performs quite well in quite a lot of metrics. But anyway, I'll hand over to James.
We're actually looking at reinstating the open fire at Orphiston Clergy House, which was our first property we bought, 1896. It has humidity in the 90s consistently all year round, and it's a real challenge. But in the Trust, we always talk about comfort heating and conservation heating. And so the comfort heating, you know, a lot of these mansions you see, what you don't realise is somebody probably lives in a top flat, or there's a donor family that still live in half of it or somewhere. And so the challenge for us is to have those two systems going at the same time. And so obviously the comfort heating is a traditional thermostat, so you turn it up to 18 degrees, it goes up to 18, clicks off. Whereas our conservation heating is much more humidity-based controlled system. And so what we want to do is to keep that low level. And what we do as a trust is the collection is more important than the people in the building, whether you're a volunteer or staff or visiting. So if it's the depths of winter and you're in Winchester City Mill and it's colder in the mill than it is outside, you put on a coat. And that's almost the law, unfortunately, for us.
Well, I think actually we need to talk about heritage buildings, but actually generally I'd argue that we've forgotten how to use buildings. We used to put on more clothes, and if we're trying to reduce the demands on our closed circuit of a world, we should use textiles more rather than heating systems. So I think the apocryphal story that after Fukushima, the Japanese government passed a law requiring employers to let their employees take off their jacket and tie in the summer so that they could raise the set point of the air conditioning, saved more energy than energy efficiency measure ever enacted before.
And that's the same in most European countries as well. It's against the law to have air conditioning set below 27 degrees in public spaces in most European countries.
So I think, the part we haven't talked, the gentleman behind, that we haven't talked about behaviour, but I think that's really critical as we decarbonise. Hello.
Hi, I'm slightly confused about the principle of heat sourcing pump. So as far as I know, in order to create like a cooling, you use a gas that you compress, and you have one side that heats up and the other side that cools down. And then you throw some air to sort of like cool or heat up the room, whatever you want to do with it. So in a country like Singapore, people are complaining because there's too many air conditioning and it has a negative impact to the environment. How did you manage to make it a good thing for the UK or for Europe by using the same technology and the same principle?
Well, the point is that fossil fuels are a one-time usage. So burning gas to produce heat for a building is obviously not sustainable in the long term. Whereas something like a heat pump system that can use renewable, sustainable electricity to generate that, to provide the energy source for that heat pump means that you can provide heat in that building without burning a fossil fuel and make that a continuously renewable zero carbon system. So obviously the refrigerant that's inside the system, that can be quite harmful to the environment if it escapes the system. So there's all sorts of legislation and requirements and necessities about making sure that the refrigerant that's inside the system doesn't escape. But in the long term, the idea is that rather than burning fossil fuels, as the vast majority of buildings in the UK do, to produce heat, using something like a heat pump which runs on electricity rather than on fossil fuel is a far more sustainable solution. And that's why, from a carbon point of view.
Yeah, I mean, a lot of the heat pumps talk about today are sort of air-water heat pumps or water-water heat pumps. So it's still radiators or underfloor heating on the end of a system. It's not blowing the air, like it's not the renewable source, it's not from the air itself. It's getting the heat out of there, but actually how the building's being heated is still radiators or underfloor heat in the same way. So I think you've got to think air-water heat pumps or ground-water or water-water is what we've been talking about today. It's not like using air to actually blowing into the building. You can do that with heat pumps, but I think a lot of the general way is air-water.
But I think that it comes back to the behavioural point. I mean, in this country, in most buildings, most of the time, air conditioning is not needed, and we should try really hard as our climate warms to adapt buildings so it's never needed, because we are lucky we live in a temperate place. If you're in Singapore where it's hot and you have 100% humidity quite a lot of the time, air conditioning, which is changing your physiological state because it's changing humidity and temperature, is probably a necessity in modern life. But there's no way you can make that argument for the UK. So the system's agnostic. How we use it is not. Last two? Okay, so well then this gentleman and then the lady behind.
Hi. Question for Dave, but also possibly for James. I'm interested in your thoughts on vacuum glazing, what its advantages, limitations, and also for James, your views on it in a heritage context, and its acceptability.
From my point of view, is what it does at the moment. We're all looking at U values of windows and what they can attain to get to document L, etc. But we're talking about listed buildings, so we can't rip out old windows and put new windows in. But however, we're trying to still get that U value up. So for argument's sake, on a heritage double glazed unit going into, maybe if it's allowed into a listed property, certainly maybe a conservation area if we're changing sashes, putting them in existing boxes. Can't give a U value for the whole window, but for centre pane value, you're talking about 1.2, 1.3, something like that. If you're using vacuum glazing, you've got a couple of advantages in the fact that you go down to 0.4 U value, you get a decibel rating of 36, so it's got really strong attributes. It's also considered in some areas of conservation now. When you look down, conservation officers, and it depends train of thought, because everyone's got a train of thought on various things, but what they don't like is looking down the side of a sealed unit and seeing the spacer bar. With vacuum glazing, you see it and it looks single glazed. So everyone's going to have a preference when you look at it, when you use it, etc. But the attributes of 0.47 U value, 36 decibels, outweighs triple glazing even.
Dave, can I add to that?
Yes.
I think there's a risk of misuse of vacuum glazing because it in some ways is a magic bullet, but we've just been involved in a project in Cambridge and our site agent was working on project next door, which is going to remain nameless, where they put vacuum glazing, which was really expensive, into old windows, and they didn't seal them or treat the frames or treat the infiltration at all. And that is literally throwing money away. So I think we just have to bear in mind the window's a holistic thing. And the U value is by no means the end of the matter. The frame and the seals probably have more influence, at least at sort of normal levels of performance. Great if you can get better centre pane U value, but actually you need to look at the whole thing and have a more discriminatory, subtle view, I suppose. Probably we should take the last from the lady there, sorry.
Hello, very interesting presentation. So I'm a historic building retrofit architect at Historic England. We are working on the revision of the current guidance on energy efficiency. And of course, we are focused on trying to help you guys. And because you've got so much experience on a variety of different projects, I was wondering if you were able to tell us what type of research or guidance you think is necessary and would help the sector.
So did everyone hear that? So basically the question is, in terms of developing best practice, and I assume legislation, what sort of guidance from the supplier's point of view and what research to back that up is needed?
I suppose an easy one to start would be the development of the UK net zero carbon building standard, which is ongoing at the moment. Heritage buildings will be treated as a separate category within the net zero carbon building standard. And obviously, I like the approach that they've taken of the way that they look at top down and bottom up. So from a top down point of view, from the graph I showed you guys before about the carbon reduction that the UK needs to make overall, whereas the bottom up being what's physically possible to achieve on a building by building level, and what is an exemplar building, what is the best that's realistic to hope for. And obviously, as long as those two things meet, what's the best that we can do and where do we actually need to get to, that's where the target is going to be set to. And I think that'll be a really helpful playbook for people to use to see, well, you know, what does good look like? What is the best that could be achieved? So that's probably, to me, the most useful thing at the moment that's being developed.
Dave, if we go to you next, what do you think?
I think from our point of view, is looking after listed building and the fabrics of the building, and coming from a different approach really. It's important that we look after these buildings, we look after the fabric, but also use the technologies that are available for us to enhance these dwellings. But you have to seek advice from your local conservation officer, planning. You have to know the area. Every area is different. You know, Article 4 direction. Some customers I go round to, they don't realise there's an Article 4 direction that's been put on the estate. You know, so we have to do a lot of digging for them, and sometimes we go back with not so pleasant news. But it's the way you overcome these issues going forward.
Steve, from your point, what do you think?
I think two simple things. Chris touched on it earlier. Sort of our electricity is very expensive compared to our gas, and if you just take one simple step, if they move some of those levies to other taxation, that would just make the running costs of a heat pump far lower, and that would really stimulate the market, both sort of domestic and non-domestic. And secondly, in terms of sort of grants, incentives, if public sector, there's public sector decarbonisation scheme, but if you're a private commercial building, there's no real pot of money. So we talk about if you have a distressed purchase, say your oil boiler or your gas boiler breaks down, it's a lot of money to suddenly sort of stump up. So whether it's grants or interest-free loans, these are kind of things that really sort of stimulate that private commercial market.
James, you probably, I suspect. I mean, if we're talking about how, I think where this is getting at is two things. It's sort of what sort of background research is needed, but also what sort of legislative and kind of fiscal framework is helpful. Because I think there's a sense that those structures are kind of exacerbating a short-termism, which is holding change back. I'd be interested to see what James thinks about that.
Fiscally, if everyone became National Trust members, that would help.
That's commercial, that's not fiscal.
I think the challenge for us in terms of research is, as aggressive as we're trying to be and push things forward, there's always that hesitation with new technologies and heritage buildings. And if you're looking after a building that's been around for 200 years, you want to make sure you're not making any mistakes with it, because irreversibility is a real concern of anything we do. And I think there is a concern sometimes, and I don't know, you probably correct me if I'm wrong, is that a lot of the new technologies are designed for modern buildings, post-war perhaps. And so how, it's tough because you're never going to get a donor, Grade 2 listed 200-year house to say, yeah, come and do what you like to me and we can be a research. Everyone's looking to everyone else to make those initial steps and to be the brave one that says we've done it. And, we make mistakes, and I've got estates that we look after, and we put biomass boilers in, and we're really struggling with them now. And the theory was there, and it just wasn't thought through correctly. We turned up, plugged it in, and said that will work, and it didn't. And we're paying the price. It doesn't harm the estate, but in terms of cost and running, it becomes a real challenge for us. But yeah, so we're trying to provide that research and work with others and say, look, here's what, part of that race, that climate race that I mentioned on, that engagement is really important for us to say, here's what we've done, here's the lessons we've learned, and can anyone else tell us what they've done?
So I was going to pick up that point, which is I think actually the UK design and construction industry is quite good at sharing knowledge compared to some places, but I think it could be a lot better. And I think the biggest single change would be, from a design point of view, is if the feedback loop was completed and people had to, by law, publish their energy bills every quarter for every building they own. It'd be a really simple upload, and it would stop people hiding, and it would be incredibly powerful. And then the other one is we should be reporting embodied carbon for every project. And sure, we'd start off really high, but there's loads of creative people. We'd soon figure out how to reduce it. But while those things are just murky hearsay, none of that lever is applied, and it's a free lever. It would be really almost free. It would be really easy to do, and the government should.
The GLA are starting to do that with the Basey, and there was also a government consultation in 2021 to make any commercial building over 1,000 square metres move to mandatory disclosure.
So if you go to the city of Boston in the USA, they've got a geographical interface. You can click on the building, see how much energy it uses. It's a very, very persuasive tool. And actually the DFE is mandating reporting of embodied carbon on new projects, but not retrofit. And I think actually that's a mistake. We should be reporting on everything, and that data should be open. And I think if it was, life would change pretty quickly for most of us in the room. Okay.
Yeah.
We're good?
The only thing I would add is post-occupancy valuation as well.
That's kind of what I mean.
Yeah,
it all comes back in a loop. So there's the qualitative aspect of that as well.
And we have that ability because we're a closed estate. We can go to the people in the buildings and say, how has this performed? What's working? And that less technical analysis and more.
We just as an example, we did a very basic POE on a school we did, which is to 2015 building regs, not a historic building, anything but. The energy they're actually using, it's a naturally ventilated building, is 2.5 times the predicted using SAP counts, which are notoriously unreliable. But I think if every council was faced with looking at that with their audit committee every quarter, life would change. Okay.
On that note, I'm going to stop you, Josh.
Yeah.
So, on behalf of the Building Centre, thank you all for coming. I would like to thank our speakers. So let's thank James and Steve and Dave and Chris and Josh for chairing. So if we could give everyone a round of applause. Thank you. I appreciate some of you had questions and weren't able to ask in this Q&A, but we are continuing the drinks upstairs thanks to REHAU. So if you've got time, please move up to the gallery, enjoy the exhibition, grab another drink, ask your questions to our speakers directly in the gallery space, and we'll be closing the building around about 8:30. So we'd love you to stay with us for another hour or so. So thank you, everyone. And we have recorded the event, so we'll share it once it's live, and please come to more Retrofit 24 events. Thank you.